CNT140 Chapter 3. We're on the last chunk of our chapter here. Going to talk a little bit about Power over Ethernet. So the IEEE issued at 3 Ethernet Committee created standards for powering devices across pairs of our unshielded twisted pair cabling. Powering devices like access points, IP phones, security cameras, that sort of thing. And this allows these devices to be placed where they're needed, not where they happen to be near a power outlet, if you will. So I can put an access point where I need the best coverage and power it from my switch. I can put security camera where it's best going to be able to observe the part of the building I need to observe, and power it from my switch and so forth. The standard was developed when there were only two unused pairs in my data cable, because 2 were being used for data and the other 2 were empty. As they moved on to later versions of Ethernet, where you start using all 4 pairs, the Power over Ethernet standards were revised to allow the use of all 4 wire pairs to handle power along with the data. So the Power over Ethernet is usually using 48-volt power to power things like IP phones, access points, etc. The power can be delivered either with the actual switch itself. I think I have here a Power over Ethernet enabled switch, and I do need to make sure when I buy a switch it's able to do Power over Ethernet. Not all switches can. I need to make sure I have one that does Power over Ethernet, and they do actually have a limit on how much they can power. Let's just say it's able to do 300 watts or whatever. If I start plugging devices and I get to the 300 watts level, as I try to plug more devices in, it's usually not going to power it. So I need to do a little homework on what am I powering, how much power is it going to use, and making sure I have a switch that's able to support that. The other way to go is if you have a switch that does not support Power over Ethernet, I can do a mid-span device, and it's basically a power injector. So going from the switch, I plug into the mid-span, that gives you the power, and then I go from there out to my device. And it's basically a power injector. And there are such things as power injectors as well, especially if you only have 1 or 2 connections that you need to power. I can buy a little adapter that you plug your data cable into it, and the data cable leaving it will have the power on those wire pairs to power the device. And again, here's a couple other examples. I think these actually are power injectors in this example, and so forth. Here's a mid-span being used over here. Switch to mid-span out to your devices. So there's more than one way to do that. The standards actually, here's the chart that was in the book. I copied it over here for you. Power over Ethernet standard, Power over Ethernet Plus, etc., and what they're capable of powering. So this would be one of those you might reference as you're dealing with buying a switch or looking at the switches you have. What capabilities does it have based on the standard? Next part of the book, they talk a little bit about fiber optics and structured cabling. Again, unshielded twisted pair is kind of the main connection used from the closet out to outlets, out to workstations. Our fiber optic tends to get used for those high bandwidth links between closets. I think that's actually the picture I have here again for you, reminding you. From the closet out to outlets and workstations, this is all unshielded twisted pair. Stranded patch cable here, solid UTP cable out here to the outlet, and then stranded patch cable out here. So that is all typically your unshielded twisted pair, because inexpensive, pretty good performance, easy to install, and deal with. So that works well for that. Where the fiber comes into play is typically between your closets for bandwidth and distance. It's able to do a lot more bandwidth, and it's able to do a lot more distance than your unshielded twisted pair can. Remember, your unshielded twisted pair is usually limited to about 100 meters. Your fiber optic in a LAN environment like this can be 300 or 500 meters in what it's able to do for distance. So you could connect closets in different wings of a building, across a warehouse, potentially from building to building in some cases, but definitely between closets and definitely between floors. Here also the book shows you a little bit about fiber can be used also for the centralized fiber, actually going from the closet out to a passive device in an area, and then coming from there over to your devices, and potentially even fiber optic to those devices too. Fiber offers several advantages for LAN backbones. Like we said, more bandwidth. Your fiber optic is unaffected by EMI, electromagnetic interference. So, anytime I have a power cord or a light that's using electricity, that is producing some kind of magnetic field around it. My copper cables laying near that, my copper unshielded twisted pair data cables laying near those lights and power cords, tend to pick up some of that signal as noise or interference. Well, fiber optic, being glass, is totally 100% not affected by those magnetic fields. So fiber optic sometimes is used in industrial environments, manufacturing plants, because all these motors and conveyor belts and robotic arms kicking on and off and moving around will be these fiber links will be totally unaffected by all those sources of interference. Fiber optic is usually smaller and lighter than unshielded twisted pair, so you can get a lot more through a conduit or a space. And a properly designed centralized fiber optic network may save costs over time, because I won't need to, I wouldn't say continually, but every 5-10 years upgrade your cabling to support more bandwidth. The fiber optic has longer length of use, if you will. Solution to cost-effective fiber in the LAN is using centralized fiber. Fiber supports longer distances to get you, and basically get rid of the telecommunications rooms. I could go from the main closet out to a part of the building and plug my devices in. So I could actually, with fiber, scatter some switches around the building with long links in between them, and that's exactly what they're trying to show you here. Centralized fiber. I would not need the closet here. I just have a passive device out here, like a patch panel, that I'm going to patch it right through to my desktop device. Passive optical LAN. This is kind of replicating your fiber to the home structure, and that's kind of what you're seeing with this stuff here. And here I have my main closet. I have the splitter going out to these devices here. I think I have pictures of those. And I think I showed pictures earlier. And then up a splitter here into your gigabit switch. And that basically now, instead of having a separate closet, that literally is my device to connect into my workstations or whatever. Here shows you two different options for doing. I think the top one up here, we have what we were looking at, where I have basically fiber to this passive device, and I run cables out to each of my devices, access points, desktops, etc. Actually, no, they're going up here to switches that we have, then we can plug into our devices here. Excuse me. The other option is, and that's a 32 pair, I can run a single mode here and then split it out to smaller patch panels, smaller bundles of patch panels, passive patch panels, and then go out to my devices. So there's more than one way to tackle this. So in some environments with distance or industrial noise, interference, that sort of thing, these kind of structures, centralized fiber structure, might work well in those environments. The last little part of the chapter, they remind us about fiber, copper, or wireless. The thing we usually think about is copper is usually your first, kind of method of connecting up devices. Fiber gets used for the backbones between closets, that sort of thing, or distance to a closet on the far side of a building. Wireless now, for many people, is that flexibility thing. There was a point in time where we didn't have wireless, everything was wired. When wireless came along, a lot of people started using wireless, but then started discovering that there were security problems. So a lot of companies, a lot of people went back to, hey, we're going to do more wired because it's a little safer, a little more secure. But then we have events like the pandemic that came along, which ended up having people work a lot more remotely or at home. So we went back to, hey, wireless is a lot more convenient for my connections. And also, to boot, our more wireless standards and security encryption have made them a little bit safer to deal with. So a lot of people now want to be mobile because of these fluctuations over time. So in my network, I can actually connect into here access points. I can plug an access point in here to handle wireless in an area, maybe a meeting area, maybe a common area that people can bring their laptops to. And the last example, they talk about, when was the last time you went to a meeting and plugged your laptop in? Well, it's been quite a long time since we did that. A lot of people are using laptops, tablets, smartphones, etc., and using the wireless connection. In many cases, using a encrypted, secure wireless connection that the building or the company is providing for you. And 802.11 standards, like we said, standards have come along to make it a higher bandwidth connection, more reliable connection, and with the encryption on top, a more secure connection than we used to have years ago. And here they're showing you again connecting the access point in here to your closet for those parts of a building. And actually, access points have come a long way where you can dial up or down the range so that I can control a certain area, not have it spill out to public areas where you might not want people to even see that access point exists. And fiber to the desktop. Some places, fiber to the desktop might be necessary for large processing needs, a lot of large data needs that a specific entity might need. Okay, power users, like they say down here. Security conscious users in some situations, but power users in some situations might need fiber to the desktop, which again is showing you here. I can use a passive connection out here, passive patch panel, fiber patch panel, and route that through to a direct desktop connection for a user. So it does have its place in some environments as well. So here's the end of chapter 3.